A group of students designed a catapult which they will use to fire water balloons at their professor. The height in feet of a water balloon launched by the students is given by the function y of t equals negative 16t squared plus 50t plus 4, where t is the time in seconds. A. What is the practical domain of this function? B. What is the practical range of this function? C. What is the maximum height the water balloon will reach? And D. At approximately what time is splashdown? To begin, if this was not an application problem, the domain would be all reals, and the range, because the parabola opens down, would be from negative infinity to the function value of the vertex. But because we have an application problem, the practical domain and practical range are the domain and range values that actually make sense in the given situation. Let's answer these questions graphically by graphing the given function using Desmos, which I've already set up on the next slide. I've also already determined the key points using Desmos. Let's first consider the practical domain, which are all the values of t, which is time in seconds, that make sense in this situation. Notice the point on the right, 0, 4, is the starting time of time t equals 0, and then on the right, the t-intercept of approximately 3.2, 0 would be when the water balloon hits the ground. This indicates the practical domain would be from t equals 0 to t equals approximately 3.2, rounding to the nearest tenth. And now the practical range is going to be all the outputs that make sense given the practical domain. Recall each output represents a height of the water balloon. So we can see at the point 0, 4, the starting height is 4 feet. Then the water balloon is launched. It goes up to a maximum height of approximately 43.1, and then from there it falls back to the ground where the height is 0. This indicates the practical range would be the function values from 0 all the way up to the vertex where the function value is approximately 43.1. Let's go back and record the practical domain and practical range. Again, the practical domain would be the closed interval from 0 to approximately 3.2, and the practical range would be the closed interval from 0 to approximately 43.1. Part C, what is the maximum height the water balloon will reach? This would be the function value at the vertex, or the maximum value of the range, which is 43.1 feet. Going back to the graph, notice here at the vertex the height again is approximately 43.1, which is the maximum height. And then for part D, at approximately what time of splashdown, that would be the maximum value in the practical domain of 3.2 seconds. That is how long it takes for the water balloon to hit the ground, which again, going back to the graph, is this t-intercept here on the right. Now if we did want to find these values by hand without analyzing the graph, we'd have to recognize that the practical domain, or times, would start at t equals 0, and then we'd have to use the quadratic formula to determine the t value of approximately 3.2, and then to find the practical range, we'd have to recognize the least value of the range would be a height of 0, and then we'd have to find the vertex by hand. To find the vertex by hand, remember, we would have to first determine negative b divided by 2a, which would give us the time of the maximum height, and then we'd have to find y of negative b divided by 2a to determine the maximum height. But I think using the graph is a nice way to approach this problem because we can analyze the graph and make sense of these values. I hope you found this helpful.